Atomic theory is a fundamental scientific concept that describes the nature and behavior of matter at the most basic level. It posits that all matter is composed of small, indivisible units called atoms, which combine in various ways to form molecules and substances. The development of atomic theory has profoundly influenced our understanding of chemistry, physics, and material science. The origins of atomic theory can be traced back to ancient Greece. The philosopher Democritus, c. 460 to 370 BCE, proposed that matter is composed of small, indivisible particles called atomos, meaning uncuttable or indivisible. Although his ideas were philosophical rather than scientific, they laid the groundwork for future developments in atomic theory. Modern atomic theory began to take shape in the early 19th century with the work of John Dalton, an English chemist. Dalton's atomic theory, proposed in 1803, included several key postulates. 1. All matter is composed of atoms, which are indivisible and indestructible. 2. Atoms of the same element are identical in mass and properties. 3. Atoms of different elements have different masses and properties. 4. Compounds are formed by the combination of atoms in fixed ratios. Dalton's theory provided a framework for understanding chemical reactions and the formation of compounds. In the early 20th century, new discoveries led to the refinement of atomic theory. J.J. Thomson's experiments with cathode rays in 1897 led to the discovery of the electron, a negatively charged subatomic particle. Thomson proposed the plum pudding model of the atom, which depicted atoms as a positively charged sphere with embedded electrons. Ernest Rutherford's gold foil experiment in 1909 provided crucial insights into atomic structure. Rutherford discovered that atoms have a small, dense nucleus at their center, which contains most of the atom's mass and positive charge. This led to the Rutherford model of the atom, where electrons orbit the nucleus, similar to planets around the sun. Niels Bohr further refined the atomic model in 1913 with his Bohr model, which introduced the concept of quantized energy levels for electrons. According to the Bohr model, electrons orbit the nucleus in specific energy levels, or shells, and they can only occupy these discrete levels. Electrons absorb or emit energy when they move between these levels, leading to the discrete lines observed in atomic spectra. The development of quantum mechanics in the 1920s by scientists such as Werner Heisenberg and Erwin Schrödinger brought a more sophisticated understanding of atomic structure. Quantum mechanics introduced the concept of electron orbitals, which describe regions around the nucleus where electrons are likely to be found, rather than fixed orbits. This probabilistic approach reflects the wave-particle duality of electrons and provides a more accurate description of atomic behavior. The modern atomic theory incorporates the standard model of particle physics, which describes the fundamental particles that make up atoms and the forces governing their interactions. According to this model, atoms consist of a nucleus composed of protons and neutrons surrounded by a cloud of electrons. Protons and neutrons are themselves composed of quarks held together by the strong force mediated by gluons. In summary, atomic theory has evolved from ancient philosophical ideas to a sophisticated scientific framework that explains the fundamental nature of matter. It has significantly impacted various scientific disciplines and continues to be a central concept in understanding the physical world.